Hello pharmapians. So today we will learn about the process glycolysis. So let's make it simplest with the help of some tricks and shortcuts. Basically glycolysis is the process of breakdown of glucose molecule with the help of enzymes to release energy with two molecules of pyruvate. Glycolysis is made up of two words glyco and lysis. Glyco means glucose and lysis means to break down. This is the typical glycolysis process which has been shown here. Basically, glycolysis process is divided into three parts. First is energy investment phase, second splitting phase, and third energy generation phase. In order to understand this process very conveniently, we will divide this process into two parts, that is part A and part B. Let's talk about part A first. In this, we have taken the first phase of the cycle, that is energy investment phase, where first of all we will focus at the intermediates of the cycle. They are glucose 6 phosphate, fructose 6 phosphate, and fructose 1,6 diphosphate. The first four intermediates of the cycles are very easy to remember. Then two, for the convenience, we will understand it by the help of diagrams. So here first diagram is of glucose. In second diagram, a phosphate group has been attached to the glucose molecule to form glucose 6 phosphate. In the very next step, the 6-member glucose ring get converted into 5-member ring to give fructose 6 phosphate. In the last step, one more phosphate group get attached to the carbon which is at the first position to form fructose 1,6-bisphosphate or diphosphate. Let us talk about enzymes now. To learn enzymes, we have a simple mnemonic which is like हंस मत पगली फूफा आ जाएगा. Each word of the mnemonic represent the enzyme at the each step. Here, H represent hexokinase, P represent phospho, G represent glucose, and I represent isomerase. P represent phospho, F represent fructokinase, A represent aldolase. Now let's move to part B. Here again we will first focus on the intermediates and then we will shift to the enzymes. As we can see here, all the names of the intermediate here are very large. So to make it easy, we will convert all the big names into their short forms. Okay, like DAP and GAP. DAP is for dihydroxyacetone phosphate and GAP for glyceraldehyde 3-phosphate. If you get confused between these two molecules, just remember that one molecule is having acetone, that is ketone group, and other molecule is having aldehyde group. Next three intermediates are quite similar to each other. They are having a common name, that is phosphoglycerate. If we convert this to the short form, it will be 1,3-PG, 3-PG and 2-PG. Next is phosphoenol pyruvate. To remember this, we can simply remember PEP, or we can follow another way, that is phosphate is common in all the steps, so we will write phosphate means phospho, and the enzyme which is engaged to form phosphoenol pyruvate is enolase, so we will write enol, and the product which we are getting is, that is pyruvate, so we will write pyruvate, that is phosphoenol pyruvate. Let's move to the enzyme part now. With large spellings and complex words, it becomes difficult to learn the enzymes of this process. To do so, we are here with a mnemonic which is like तुझे परसों इसके घर पे पार्टी के पहले एंट्री कैसे मिली. Here each row represents the enzyme at each step. T for triose, P for phosphate, I for isomerase, G for glyceraldehyde, P for phosphate, another P for phosphoglycerate, K for kinase, P for phosphoglycerate again, M for mutase, E for enolase, and K for kinase. At 6th position, the enzyme is glyceraldehyde 3-phosphate dehydrogenase. glyceraldehyde 3-phosphate comes from the immediate previous intermediate in the cycle, and we have to just add dehydrogenase here. And at the last step, that is at the 10th step, we have kinase enzyme. Just we have to add pyruvate. Now let us talk about the arrows and the byproduct. In part A, we have alternative arrows, like first is unidirectional, second is bidirectional, third is unidirectional, and fourth is bidirectional. In part B, all the arrows are bidirectional except the last one. If we divide the diagram in this way, so in first phase, very first and last arrow is having ATP to ADP. Next, immediately after splitting phase, we have 2 NAD plus to 2 NADH. In the last part, it will be similar to that of the first. The only change will be here ADP will be converted to ATP. Thank you so much for watching. If you like this video, then do motivate us by hitting the like button, subscribing our channel, and sharing with your classmates.